be wrong when we get there on the AP, right? Okay, whew, ratio root. We hinted at yesterday, it's really good for factorials, and it's really good for things to the n power. If we take the limit of, now careful, this is an nth term. Why? It's not just a sub n. Do you guys see it? It's a limit as n goes to infinity, kind of like limit comparison, but we're not doing a sub n to b sub n. We don't have to go find somebody new. It's a good thing. We're just looking at the n plus first over the nth. Didn't we talk about a lot yesterday how to find the n plus first? Oh wait, what did we forget? Well, we didn't really forget it, but it is another endeavor card. Remember with alternating how we can estimate by looking at the next term? That was yesterday. Error, remainder. Okay, something, another forever. Endeavor. That could be on the quiz. Sorry, coming back. But the nice thing is, didn't we talk about a of n plus 1, a sub n plus 1? You plug in n plus 1 to the n spot, right? Function notation. It's taking the limit of the n plus first over the nth. Wait, dividing by somebody is the same as multiplying by his reciprocal, so we're going to do some of that. If we can get the limit, well, when we solve the limit. Root test. If we solve the limit of somebody raised to a root, 1 over n. Or the 1 over nth root, I should. That doesn't make sense. The nth root or the 1 over nth power. Limit. Whatever's going on. If the limit is less than 1, what do we know? Converge. Limit is greater than 1. What do we know? Diverges. Limit equals 1. Okay. I've tried to make sense of all the other tests for you as far as why. This one, to be honest, I'm kind of a just go on faith. I know. I'm sorry. It's a little rough. You could think about if the limit is less than 1, can we say that the bottom wins? Not really, because it's not 0. We're not even talking about degrees. That's the struggle. But it's okay because we're not comparing two separate sequences. We're comparing an n plus first term and an nth term. It just starts to get a little bit messy as far as making sense. If someone, I can try to think about it a little bit more. Just naturally, off the top of my head, I don't have a y. And I know, I'm sorry. However, even though I don't have a y as to comparing 1, well, 1 we could just say is completely tied. Coefficients, degrees, the whole shebang. No, still it doesn't help. I was trying to make it help. I'm just going to stop talking. But as far as remembering, as far as memorizing, if you get 1 down as the separator, if you get 1 down as the key guy as far as less than, greater than, or equal to, if you get 1 down, we can think in some ways less than, okay, lower, maybe convergent, greater than, maybe divergent. You could kind of think of, what test am I thinking of and why am I not going to it? Sorry, it's really fuzzy and ambiguous in my head. I'm thinking of limit greater than 0, but that's not helpful. What one does, the other does. Never mind, there was a comparison, but it's gone in my head. But in my head, less than makes more sense with convergent and greater than makes more sense with divergent. But that doesn't help you guys at all. It's just a studying trick. That's all that is. I'll see if I can get anything else better on the why. But for right now, we're just going to go on faith. Sound good? It is a rule. It's an endeavor. We get to memorize it. We get to use it. And it came from people wiser than us. So, what did I do yesterday? What do you guys see me doing? Ratio or root? Yeah, ratio is a division. Ratio is a fraction. Ratio is an n plus first over an n. Could you write this every time? I guess. Or couldn't you just put the reciprocal? Is that cool? So we have the n plus first times the reciprocal of the nth. It's going to kill me before the end of class. Factorials. Oh, how did I get 1 over n plus 1? Isn't this guy everybody 1 up to n? Isn't this guy everybody 1 up to n and 1 more? Remember yesterday how we were simplifying? What's the nice thing of this guy? His limit is 0. What's nice with 0? It's less than 1. Okay, it's maybe something else to help you think convergent. 0 is less than 1. Convergent is less than 1. Anyway, we can basically say, by what test? By the ratio test. Were there any ifs with the ratio test that we have to be careful of? I think there is, but I might be wrong. Was it positive terms?
Oh, yeah.
Oh, okay. Okay. So positive terms, we can't use it strictly for alternating, but we can use it with the absolute value for alternating, I suppose. Hey kiddos, look at number 2. Why not just do geoseries? He's not geo. Does that, you see it? Okay, why not just use nth term test? The limit 0, we know nothing. Why not just use a comparison? Oh, 1 over 2 to the n, just ignore the n. 1 over 2 to the n. Okay, cool. So infinity. Oh, convergent, infinity, nothing. Direct comparison. 1 over 2 to the n is always going to be smaller. Smaller converges, nothing. So maybe the ratio test is really good when we have very dissimilar numerators and denominators, and we're like, oh, well, maybe we just want to compare it to itself. How do we compare it to itself? Or how do we just work with itself and not have to go looking for someone else? Ratio test. Ratio test says just look at the n plus first term. Ooh, exponents. Do we remember how to simplify exponents from algebra? Oh, that's one way. No. That is one way. You can do n minus n plus 1, but some of you would forget to do n minus 1. Distribute. I think it's a lot easier, and correct me if I'm wrong. Ignore me if you have a better way, but I would make this 2 times 2 to the n. It's easier in my head. Because n plus 1 means there's a 2 and there's a 2 to the n. If that's not easier, it's okay. Do the subtracting thing. Just don't forget to put him in parentheses. Either way, you end up with a 2 to the negative 1, but in my head, it's just easier to think of addition of exponents came from multiplication of like bases. Wait, so what's the limit? You guys see it? Because aren't the degrees now tied? The only places where n is left. And what's the ratio of the leading coefficient? 1 over 2. Ha! No. Not comparing to 0, comparing to 1. Less than 1. I know it's hard. It's hard. It's hard. It's hard. Maybe it's something where you think of a sub n plus 1 over a sub n. If the ratio is 1, we know nothing if the next term is the same as the last term. I don't know. I'm just brainstorming. Maybe some of you guys will have a light bulb and be like, oh, it's because of this, I think. And we'll just use it. But what can we say? By a ratio test? Is the limit as n goes to infinity of a sub n plus 1 over a sub n is equal to 1/2 less than 1. If we did want to make it all nice and pretty, that would be our answer, right? I probably won't write too many more nice and pretty ones because I just want to get you guys practice. But are we good with the general gist? Do you guys see how we don't want to do integral tests? There is no geoseries. Limit comparison, direct comparison. I don't know what to compare it to. It's a good question. Root would say, hey, I can get rid of the n by doing 1 over nth power, but how do you do n factorial to the 1 over nth power? This one would say root test. This one would say ratio test. We have to pick one. I would say go ratio. Why? I don't know how to do the nth root of n factorial, and that's not one of our special converging sequences. We don't have n factorial to the 1 over n, sadly. I would do ratio. This would seem to indicate root, but no. I would do ratio. And remember, didn't we just say ratio can be helpful when you have two very dissimilar numerator denominators? You guys go. Get at least 30 seconds ahead of me. N plus first term over the nth term, or times the reciprocal of the nth term. Let's see if you can analyze it without me. Oh, I have not taken attendance at all today. Everybody's here but Daniel, right? Bless you, bless you. Check in your groups. Let's see if they agree. Have you guys gotten correction papers yet?
Yeah, wait, I did my I just forgot to turn it in.
Oh, you mean about the old one? Hi, guys.
What number is Justin?
Issa for you and Justin. Hannah for you guys.
Oh, for the
Yeah. Oh, didn't get enough.
I already did.
Who didn't get one? Oh, Sally and Carrie, you didn't get one, right? And you guys didn't get any? Yes, I think so.
Can we do ratio tests? Or can you do root tests with a ratio test?
Yeah.
Can you do 2 tests in one or no?
We've ended up with n plus 1 to the n over n to the n.
Sorry, Justin.
I'm just confused on where to go from here. Once I do the n plus 1 and multiply times the reciprocal.
You can simplify the factorials, right?
These?
Mm-hmm. Remember, n factorial is 1 through n, because it's counting by ones, 1, then 2, then 3. N plus 1 factorial is 1 through n and n plus 1. So the 1 through n's reduce. Carrie, Hannah, Sally, these are already in RenWeb. Maybe you guys have stayed away from your RenWeb. They were in there yesterday, I think. They're sad. They're sad. But corrections will get points back. And I bet after all of this time, you guys will be able to do the corrections very quickly. Because this was all very new when you took the quiz. Do you remember this? And there were things like conditions. Yeah. I might have kind of been falling asleep on yours, so it's a little messy, but it's all there. I just whited out the random extra marks that meant nothing. That's a Starbucks. I was trying real hard. It was out of 20, but lots of you scored less than 10. So it was a little rough. But I think what this test was on, geometric, nth term, integral, geoseries. I don't think it's that hard anymore. And a lot of you guys that were like, oh, the limit equals 0, so it converges. We know nothing. Or you were like, we know nothing, let's move on. I'm like, okay, so figure out what we know. We can get those points back. Now, not entirely, I can't just be like free points all the way up to 100, but we can do the half point thing. Sound good? Okay. Okay. Can I start playing? We will have chances, guys. You have, well, not an entire week, because we should probably correct this before the test, right? But you will have class time tomorrow at the beginning of class and Tuesday at the beginning of class. I would love to get these turned in Tuesday, because you guys need to move on past this towards the test review, et cetera. But you should look at your mistakes, and I bet you'll be like, oh my goodness, I didn't know that then. I think you should know it now. Sound good? Okay. Do you guys do n to the n plus 1 all over n plus 1 factorial times n factorial all over n to the n? Did you rewrite this? Now, just in case a few of you still don't know factorials, you always just go 1 up. So you go from n to n plus 1 to get n plus 1 factorial. you guys think of splitting him up?
Don't you do this one side, like at the base as well?
Ooh. Because how many ends did we have? Well, we had an end there and an end there, right? Okay, so we could do that, right? Is that true? Okay, so we cancel out all of those with all of those. We could cancel out that with that, and we're left with the limit as n goes to infinity of n plus 1 all over n to the n. True? Because right now we have 1 to the infinity. Is 1 to the infinity anything special? Oh, come on, you guys, you're killing me. You're killing me. Come on. Oh! E. No, I'm completely honest, because isn't that a special converging sequence? 1 plus 1 over n all to the n? Oh, how quickly you forget. E, 2.71828. Isn't 2.71828 greater than 1? Dun, 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 dun. It diverges.
That's exactly right.
Wait, can you explain what you did to the numerator? I don't understand that.
Yeah. Sorry, between what and what point, though? Here? Okay. Remember when you have plus 1 with powers? Addition of powers comes from multiplication of like bases. So whenever I have n plus 1 up there, I had 2 to the n plus 1, which was 2 to the n times 2 to the 1. This one, n plus 1 to the n plus 1, is n plus 1 to the 1 times n plus 1 to the n. So then I was able to go ahead and cancel out my 1 through n because of the factorials. I had an additional n plus 1, but they reduced. I saw them both to a power. So I can go ahead and say, well, if the numerator is to a power, denominator is to a power, the whole fraction is to a power. And then I was like, oh, look, it's e. I was like, oh, look, it's e. You guys are still getting there. Isn't that an Endeavor card, though, the special converging sequences that we need? Okay. I know. Wait! So who's stronger? Who seems stronger, according to this? Just who seems. I'm not making you guys say a definite. Who seems stronger? Well, technically, the limit can be 0 and still have it diverge. So I'm saying who seems, not definitely saying so, because the bottom could still be stronger, but couldn't the top still be stronger? How can this diverge? Well, the limit be 0 and still diverges, or the limit be infinity and it diverges. Huh. I don't know. I'm not sure if this answers the question, who's stronger. But it definitely doesn't tell us for sure which one isn't. What do you guys think? Ratio or root? Just pick one and I'll go for it. What do you want?
Ratio. Oh, okay.
You want to try root? Okay. Limit as n goes to infinity of the nth root of 2 to the n all over 4n squared minus 1. Another way of writing that is how your test writes it, which is n to the infinity of, with numerators and denominators, we can actually do them separately. So we can do him to the 1 over n, but we can also do him to the 1 over n. So now what? Isn't that, I'm not going to do an equals because we've already kind of looked at that and how it's kind of dangerous, but that is going to, well, that does equal 2. But this one is going to infinity to the 0. Is that determinate or indeterminate? Indeterminate. Well, that's a struggle. So, L'Hopital's? Problem is, how do you take a derivative of a f to a g? Don't you need an ln? Maybe we should try ratio. Want to try ratio? Okay, let's see if it's any better. You guys realize that sometimes I have no idea where a problem is going and we're just going, right? That's dangerous. Definitely not true. If anything's infinite, it would be my weakness. But good thing God's strength is infinite. Okay, so we have 4n squared minus 1. Can I just leave it with the 4 and the... Hey! I like ratio. Why? Can't I just say the degrees are tied? Sweet. Because it's an n squared and an n squared, true? So what's the ratio of leading coefficients? Well, that's going to be an n squared times 4. That's going to be an 8. Oh, it's 2, which is greater than 1. So what do we know? Diverge. Is that okay? Why am I trying to write by what test? Because what do I want you doing on the test? Uh-huh. I need you to know what test you're using. Well, and I need to know what test you're using. Now what?
This one we can do what is it called, the root?
The root test? I say right now it's illegal to use either one.
Oh, it's an alternating series. Oh my lord.
But when wouldn't it be illegal? If you wanted to test for absolute convergence first, could you? I suppose. Well, nth term is going to be 0, right? Now, I'm not saying necessarily, because some of you would start with step 1 and step 2 and then go looking at this series, but eventually, well, hold on, step 1, step 2, let's just do that. Limit as n goes to infinity of a sub n is 0 because the bottom degree wins, right? He's 1 and he's 1/2. Okay, well, what's going to happen if we look at the n plus first term? Well, he's n plus 2, so he's a little bigger than, but he has a square root over him, whereas he doesn't? Well, it's kind of illegal to separate square roots, sadly. I wish we could. Could we take derivatives and show for sure it's decreasing? Yeah. But wait, pause. Couldn't we kind of be cheaters and be like, well, the square root of 1, that's going to be a smaller number than 1? To some degree? Or at least it's going to be tied. So when we're adding a whole 1 in the bottom, it's going to be less than adding partial ones. Now, it's not truly the square root of 1. Remember, we can't distribute square roots. But doesn't this get cut into a half power, right? Whereas this is a whole power. So anyway, all that to say, I would say you're adding more to the denominator than the numerator, just like quick logic, which I guess that's dangerous. So then this truly is decreasing. Well, the way that I would prove it would be like if it was an FRQ, would be a derivative. You'd have to show decreasing that way. I'm not so sure that just, I mean, you could just state it and hope that they take your BS answer, but I don't know. But coming back. But if we know it's convergent, what extra all right, so we have to consider n equals 1 to infinity of square root of n all over n plus 1. Could we do a direct comparison? Maybe. Could we do a limit comparison? Maybe. But we're trying to, do something new. So what do you want to do? I like the ratio better. Are you guys liking it more? I mean, we haven't really seen the root being used. Well, more than the root, but we haven't really done it. Yeah. Yeah. No, that's hard. No, that's hard. To be honest, in my head, I think a limit comparison test would be the easiest one on this one. In my head. But let's see if the ratio one works. So maybe you might be thinking the limit comparison, what would you compare it to? Hey, let's figure out what that would be. 1 over root n is like the degree, and if we... But we could try the ratio and see if it could work. Oh, wait. How come it's not that bad? Degrees. Oh.
Oh my gosh, the test failed.
Do we want it to equal 1?
No.
Well, it was super nice until it wasn't. So maybe we should go do limit comparison. Okay, hold on. Did you guys know what I was saying when I said like the overall degree of the numerator denominator is like a 1 over rad n? Do you know what I was saying? Because we're trying to compare this guy. Why would I compare him to 1 over rad n? Which, by the way, 1 over rad n, doesn't he diverge p series? P equals 1/2, which is not greater than 1. Why would I compare him to this? I'm not even doing the whole direct comparison. I'm too lazy. But what happens to my degrees now? They're tied. Do I mind if the limit is 1 here? No. I prefer it, yeah. So now I can say, hey, whatever one does, the other does. So therefore, not by ratio test, but by limit comparison test.
We don't have to write on explanation pages. That's it.
Well, you showed me that this one's divergent and then greater than 0. Why? Does that diverge or does this diverge?
Oh my gosh, this is sipping.
Is it, or are we just looking for things to watch out for? I just lost my entire answer. I'm going to go do it with a computer. Beep, beep. So all of that was an aside for absolute convergence. So we say, oh, our original converges conditionally. And we did do the alternating series test. Wait a minute. Okay, most of you, the test is the farthest thing from your mind right now. Or you're trying to make it the farthest thing from your mind. But hold on. So did we just, in one problem, do the alternating series test and the limit comparison test? And p-series test? In one problem? Huh. So could you maybe go looking for another problem with one or the other and be like, well, I used p-series here, but my real p-series one is going to be over here, so this one could have been my limit comparison, or this one could have been my alternating. Some of you that are like, haha, I did 3 in 1. Remember, I said I want one problem for each test, but do some tests need more than one test in it? Yes. I know, but how many series will I be grading? 10. What if you only do 7, 8, and you're like, oh, this one has 3? Nope. I'll take away those 2, being like, you should have showed me 10. I know, but I'm just letting you know now. Because if you're like, nah, I'm working the system, I'm telling you no. Now, why is it a good thing, though, if one problem uses 3 tests? You can make it whichever one you need it to be after you look at the rest. Does that make sense? Okay. Just a heads up. Do we have anything else? Wait. So do we ever use ratio test? Maybe I shouldn't have used that as a lead-in, because now everyone knows what we're going to use. But you guys try to take the forever card to try the ratio test on this guy? Justin, you had a question. I'm sorry, bud.
Yeah, I was on the last one.
Oh, the last problem. I'll dual page it. Do you guys have this one? N over 2 to the n? Oh, I'm sorry. I meant root. Yeah, can you try the root test on this guy? I'm not saying ratio test doesn't work. I'm just saying try the root test. Yeah. They should be. I think there was one day at some point that we might not have recorded. I don't remember what we were doing, but it was a partial. If not, email me and then I'll find it on my computer. Justin, I'm sorry. Which one?
So,
or which part?
on the left side,
Yeah.
why did you go on with the alternating series test?
Oh, because I was going to go absolute value, and then I was like, oh, but remember, absolute value, if it converges, we're good, absolute, but if it doesn't converge, we're not good. So I was like, maybe we should just be safe because it's going to be a long problem to check first whether or not it converges at least. Does that make sense? Yeah. So we were about to go, and I was like, oh, this could get messy. So then we came back and then figured out, okay, at least it converges, but how? Oh, conditionally. All right, you guys are trying root. Man, they're both R's. I just get them all mixed up. Limit as n goes to infinity. The terms are all positive. I apologize. I'm not continually saying that. But the terms are all positive. 4 values between 1 and infinity. I have n over 2 to the n. You can do the nth root or you can do the 1 over nth power. It's the exact same thing. When you have numerators and denominators, the nice thing about roots is that you can, radicals, you can apply them to the top, apply them to the bottom. So that ends up equaling, isn't that 1/2 times? Hey, is n to the 1 over n somebody special? Yeah, he is. What ends up happening? This is infinity to the 0. This is technically an indeterminate unless we have memorized our special converging sequence that says, no, 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 this one we can actually always say is, James is checking it for us. I think it's 1. Is that right? Yeah. Oh, so what do we know? By the root test, right? It's so easy. Oh, I was meant to do my therefore 3 dots. Could you have done ratio on this? n plus 1? Yeah, I think so. Ratio is technically the more useful, but every now and then root gets really useful as well. I don't think we've found one where we have one specific. Ooh. Could this be a homework problem? I don't know. It's in the homework, but maybe it's not a homework problem. Ratio test. I suppose we could do it, but do you guys see little n's all over the place? So wouldn't it be nice if we could just do the nth root and just think about that? Guys, ratio test, definitely the easiest. Ratio test, I think definitely the most applicable. But root test has its own perks. Because if I can just do that, then I can say, oh, hey, that's 0, and 0 is less than 1. So there could be ones where the root test is necessary. So far, we've only seen ones where the root test works. But just be aware when you get to homework. They're both going to be fair game. R's, you're taking the limit as n goes to infinity of either a ratio of an n plus first over an nth and then comparing to 1, or the nth root and comparing to 1. You can know convergence or divergence based on the comparison to 1 as long as the limit doesn't equal 1. If it equals 1, we know nothing and we stop and we give up and let me take away all the points. Nope, we keep going with it. Okay. With that, cool kids. I don't know. If you guys want to play with that one, you can. Otherwise, let me pop up your homework. Does that sound good? Were we supposed to grade something today? Section 9.5 had no evens. Okay, well, we had nothing to grade, but maybe we could have gone over questions. Did we go over questions yesterday, though? Oh, the error bound. We didn't go over those questions. Okay, remind me beginning of class tomorrow for us to go over questions 9.5. There are no evens to check. Somebody said 9.3. I didn't put on the scan PDF number 79, so you're not doing it. Don't worry about it. And section 9.4, don't worry about it. I never came up with a problem. We're fine. We're practicing all of them over and over again, right, guys?
Are we going to start reviewing tomorrow then, or are we doing more 9.6?
We're going over 9.5 questions, 9.6 questions. We don't really have more 9.6, but I will have a copy printout that will get us towards the reviewing stage. Yeah.
But 9.6 doesn't do till Tuesday.
Yeah, because I didn't necessarily want to force you on Valentine's Day. Not that you guys have like huge plans. I don't know. Maybe you do, maybe you don't. But I was like, let me make the 9-6 due on Tuesday just in case we needed to cover more tomorrow, which I don't think we really will. So I'd have 9-6 fully attempted tomorrow because you will get a handout tomorrow that's going to be basically a lot of series that you're going to try to find your 10 tests on. Does that make sense? Okay. Yeah. I haven't posted on Google Classroom yet, I don't think. I don't think I'm giving you a test review in the actual book on this one. I think I'm just giving you that big old page of series. Yeah. Guys, you good? All right. Happy Valentine's Day. Share the love, even if it's just friendship. I'll see you guys later.
Oh wait.
No, you're okay.
Okay.
That was an extra one.
Thank
Thanks,
you,
Kathy.
Misty.